Hello all, welcome to my YouTube channel Know About Embedded Systems. In today's video, we're going to understand Autosar layered architecture in detail. In the previous video, I have explained only three major layers of your Autosar, nothing but your application layer, RTE and BSW layer. So in today's video, we're going to understand three more sub layers of your BSW. That's what you're seeing here. These three layers, like we have application, we have service layer, ECU layer, ECU abstraction, and microcontroller abstraction layer. In detail, we will study in this video. So before starting the video, if you're a new viewer to my channel, kindly subscribe my YouTube channel, click on bell icon, and share this videos to your friends and colleagues. Let us start the video. Autosar layered architecture, session number 2. So guys, in the previous video, I have already explained about the base three layers of your Autosar, nothing but your application layer, runtime environment, and BSW layer. So if you have not watched that video, I'll update the link in the iCard. Please watch that video as well. So guys, in our Autosar, we have three major layers. One is application layer, RTE, and BSW. Thus, in a simple way, I'll try to explain once again here. We have application layer. So this application layer, the responsible for developing the software for your exclusive application. Nothing but if you're developing your ECU for your Airbag, means this software, nothing but application layer software, is responsible, or the software what we're going to develop, that is exclusively for your Airbag. Similar to that, engine control and braking system. So these are all like domain specific or application specific software we're going to develop in application layer. That's why it's called as application layer. Then we have second layer, runtime environment. This is our second layer of your Autosar, runtime environment. This runtime environment will be acting as an interface between your application layer and BSW. So for BSW and application layer, there will be no direct contact. If you want to transmit any information from application to BSW, you have to use RTE. RTE is going to be acting as a interfacing layer between application layer and BSW layer. And then we have third layer called as a BSW layer. So BSW stands for base software or a basic software layer. So under this basic software layer, we will be having different services like network management, memory management, diagnostic management, and also our microcontroller abstraction layer as well. All these things you can see in the BSW layer. Okay, so in today's video, we're going to concentrate on BSW layer, or sub layers of your BSW layer. Let us continue. Currently, what you're seeing on the screen, this is how the sub layers of your BSW looks like. So this is your application layer as usual. So this is your application layer. So we have application layer, microcontroller is there, microcontroller, and we have RTE here. Here also we have RTE. So there is no much complications. There will be complication in developing the software, but the layer classifications are not available for application RTE and microcontroller. So there is only the classification available only in BSW layer. So complete BSW layer is divided into 3+1 sub layers. So in the first layer is called as service layer. This is the topmost layer of your BSW. Then we have ECU abstraction layer. Then we have MCAL, that stands for microcontroller abstraction layer. And then we have complex device driver. So totally there are 4 sub layers available in the base software. So we will study one by one. What are the service layer? What is the ECU abstraction? What do you mean by CDD? What do you mean by MCAL? So MCAL stands for microcontroller abstraction layer. So what is the main functionality of this MCAL? MCAL stands for, you know the definition. MCAL, the full form of MCAL is microcontroller abstraction layer. So currently whatever I'm highlighting, this is your microcontroller abstraction layer. What is the functionality of this? The microcontroller abstraction layer is responsible for interacting with the physical circuit of your microcontroller like this. This is actually the software, nothing but a driver software, which we're going to develop to that particular microcontroller. Only this layer is dependent on the microcontroller, and rest all the layers, application, RTE, a service layer, and CDD, all these layers are not depending on hardware. Only the MCAL layer is depending on the hardware. So that's why. So we have to develop a different driver programming for your MCAL with respect to your microcontroller. According to the microcontroller design, we have to develop the software for your drivers for in a MCAL layer. Now let us see the definition of this. So what is this MCAL stands for? You know that already. MCAL stands for microcontroller abstraction layer, and this microcontroller abstraction layer is responsible for abstracting other layers. from the microcontroller. So that means this is only the dependent, and other layers, whatever you're seeing, all these layers are not depending on your microcontroller. Okay, now the software, second point, the software what we're going to develop for this MCAL, that is nothing but your drivers. We're going to develop a driver for in a MCAL layer, and that driver program is going to interact with your microcontroller hardware. So whatever we're going to develop the code, that code is going to interact in a with respect with the microcontroller. Okay, that is the second important thing. Third important thing, so what are the different drivers we're going to develop in MCAL? So we're going to develop your digital input output circuits, drivers, DIO we will call digital input output circuits, the ADC drivers, PWM drivers, GPT, nothing but general purpose timer. GPT stands for general purpose timers. Then we have serial communication drivers, nothing but SPI, I2C, UART, LIN and CAN. The drivers related to serial communication. Then we have crypto services like secured hash and advanced encryption algorithm and so on like that. Okay, so like this, MCAL is responsible for creating the abstraction for upper layer, and also this MCAL is responsible for interacting with the microcontroller. But the second important layer under Autosar and under BSW is ECU Abstraction Layer. So this ECU Abstraction Layer, so currently whatever I'm going to highlight, this is your ECU Abstraction Layer, and this ECU Abstraction Layer is a second layer under BSW, and this is again abstracted layer. So microcontroller layer, MCAL layer is not abstracted layer with respect to hardware, but ECU Abstraction Layer is a abstracted layer compared to your microcontroller MCAL. What is the responsibility of your ECU abstraction layer? ECU abstraction layer is responsible for deriving the different interfaces, deriving for different APIs for interacting with a service layer, or to interact with the application layer, or to interact with the runtime environment RTE. And also this is responsible for interacting with the microcontroller. So that means the ECU abstraction layer is responsible for creating an intermediate interface between upper layers and lower layers. That is the main responsibility of your ECU abstraction layer. So ECU abstraction layer, it's a mid layer. It sits in the BSW, and it will be acting as an intermediate layer between runtime environment and your MCAL. So what is the main functionality of this? The main functionality of this is to create different APIs. So by providing hardware independent APIs are nothing but function calls. So by providing hardware independent standardized APIs for accessing the peripherals. Okay, so like sensors and actuators, it's going to provide different APIs in order to interact with different APIs. Okay, next point. The important thing is, from this point onwards, we're able to port to different ECUs or different applications or different OEMs, except this MCAL layer. So only MCAL layer you cannot port to different ECU or different applications. Except this, all other layers like from ECU layer, CDD layer, service layer, RTE and application, all these things easily you can port to the different OEMs. Our next layer is called as a CDD, that stands for complex device drivers. That is, you can see here, this is called your complex device drivers, this part. So this is also one of the very important layer under Autosar. How it is important, I'll tell you now. So guys, if you want to transmit any data from microcontroller to application layer, let us assume I have some data here and I want to transmit from microcontroller to the application layer. So if you want to do that, you have to follow this path. So from microcontroller, it is going to be connected to the data will be connecting to the microcontroller. Data will be connecting to the microcontroller. From microcontroller abstraction layer, it is going to be routed to the ECU abstraction layer. From ECU abstraction layer, it's going to be connected to the your RTE, then RTE it is going to connect to the application layer. So this is the path you have to follow in your Autosar environment whenever you want to transmit any data or whenever you want to receive any data. So for both process, Whenever you want to transmit any data, you have to pass this path, and vice versa as well. But during this, it will take some time. So whenever you're transmitting 3 to 4 layers, like we have a MCAL layer, we have a ECU abstraction layer, then RTE, then we have application layer, right? So you have to cross 3 to 4 layers, and it will take some time to cross each layer. Okay, but some applications I don't want to take this much delay. Let us assume this is taking something like maybe 10 microsecond. Let us assume 100 microsecond. This path is taking 100 microsecond, but I do not have that much of time. So as soon I get an application, as soon I get a data, I need to connect to I want to connect directly to the your application layer. So in this scenario, the CDD will come into picture. Whenever you want to bypass all the Autosar layers, then use your CDD. So when you use Autosar layer, it will take some time. It will take minimum time to cross each layer and to reach your application layer. So instead of that, there are some very critical applications like airbag system, a braking system, or maybe some fuel injection or engine failure information. So in that situation, we do not, the time plays a very important role. In that situation, we will use CDD here. The CDD, when you're using directly, the microcontroller is going to connect to CDD. From CDD, it is connecting to RT, then immediately it will connect to the application layer. So this is the advantage of your CDD. I hope you're clear. Now let us see the definition what I kept it here. So this layer is used for complex functionalities which are not found in the your basic software. Okay, so that's what I told. This layer is used for complex functionality which are not defined under Autosar. Okay, next point. It fulfills the special function. So that means that's what I told you. It fulfills the special functions which are having a time requirements needed to be operated in a very less time. Very precious information from the sensors and actuators. In this situation, we are going to use complex device drivers, and some of the functions may not define under Autosar, and then we will use CDD. So example like fuel injection, controlling electrical valves, position, incremental detection, and so on like that. So very critical application which are having some time criticality. Such applications we will use CDD, complex device drivers. The fourth layer under our BSW is service layer. So under this service layer, Autosar will provide a different services for different applications. Like one is Autosar operating system. Autosar is having its own operating system. That Autosar operating system will come and sit in the service layer. Next, memory services. Whenever you want to read a data from the microcontroller memory, or whenever you want to write into the NVMe memory, and some of the failures, whenever your data is not saved properly, or whenever you're not able to retrieve data properly, then we have to log some memory related errors. For that purpose, we will use memory services under service layer. Diagnostic services. So whenever you want to read any error information from the memory, we will use diagnostic. There are different diagnostic services are there. Like we have diagnostic event manager is there. Then we have unified diagnostic service is there. Then like that, different services are available under diagnostic service under service layer. Then communication services. The communication services, if you want to transmit any data from external world to the external ECU to our ECU, then we will use a different communication service: reception, transmission, logging the error. If the frame is timed out, we have to log an error. If the data is not coming properly, then we have to log the error. Such services will be provided under service layer. Network management, like how your ECU should behave, when it should go to sleep, when it should be wake up, and when it should receive data, when it should transmit data in a network. And such informations are going to be configured under NM, that stands for Network Management Service. ECU management service. What should be the ECU turn on time, turn off time? What type of frames it should transmit and receive? All such information will be configured under ECU state management. That is also coming under service layer. Watchdog management. So in the microcontroller, we'll have a different watchdog timers. Like we'll be having system watchdog timer, external watchdog timer, and different watchdogs timers will be there. Like when the watchdog timer should be triggered, when the watchdog timer reset should happen, and what situation the watchdog timer should be in idle. All these configurations and services will be provided under watchdog timer management under your service layer. And then we'll be having a different crypto services. Under this crypto services, we'll be having a crypto key manager and a crypto service manager and intrusion detection system manager. Like this, under crypto service also we will be having a different services. We will be having key manager, as you know, that key manager in the sense which is responsible for managing the private and public key. Crypto service manager, so different services provided by the crypto, and intrusion detection system, nothing but if any unauthorized data transmission is happening, unauthorized data is reception is happening, so all those things will be detected under intrusion detection system. So these all things will be coming under service layer. Okay, so this is in a short way I try to explain Autosar layered architecture, and this is a very important thing you should know if you're going to any automotive companies. Okay, so I feel this video is clear to all, so please share these videos to your friends and colleagues, and click on like button and subscribe to my YouTube channel. Click on bell icon as well.